Okay, the quiz was a little bit more challenging. Okay, there were some formulas you had to use and you had to think about a little bit also. Okay, sine of theta is 4/5. Theta is between 0 and pi over 2. That's first quadrant, but that does not mean anything about second quadrant. Okay, in fact, it turns out that 2 theta will end up being in the second quadrant, as we shall see. Okay, the cosine of theta is 3/5. You can either draw yourself a triangle, or you can use a squared plus b squared equals c squared for that. Okay, so I drew myself a triangle. I did this method. So sine is opposite over hypotenuse. So I went 4, 5. That makes this side 3. So the cosine of theta is 3/5. Okay, now for question number 2 especially, some of you thought, well, the answer is negative, but I'm in the first quadrant, so the answer should be positive. No, you're actually not in the first quadrant anymore. Theta is in the first quadrant, but 2 theta would not be in the first quadrant. So some of you kind of outthought yourself. The answer should still be negative for number 2, as we shall see. Okay, now, what about theta over 2 for questions 3 and 4? Now, theta is between 0 and 90 degrees. Well, if you take theta divided by 2, you're now between 0 and 45 degrees, so you're still in the first quadrant. So even though the formulas might say plus or minus, okay, the answer should be positive. Okay, so for 3 and 4, the answer is still going to be positive. Okay, so those are some things to watch out for. Okay, so now that I have sine of theta is 4/5, cosine of theta is 3/5, I can plug into the formula. So formula for sine of 2 theta, 2 sine theta cosine theta, 2 times 3/5 times 4/5, 24 over 25. Cosine 2 theta, and this is what trips some people up. Okay, if you go cosine squared theta minus sine squared theta, 3/5 squared minus 4/5 squared, 9/25 minus 16/25. It is negative 7 over 25. Okay, some of you changed it to positive because you thought, wait a minute, I'm supposed to be in the first quadrant. That's true for theta, but not for 2 theta. Okay, if you double an angle between 0 and pi over 2, between 0 and 90 degrees, right? Well, if you double it, then you might be in the second quadrant. In fact, in this case, you are going to be in the second quadrant. So it's okay for the answer to be negative. Okay, now, not for 3 or 4. Again, you're given the angles between 0 and pi over 2, between 0 and 90. So if you cut that in half, you're now between 0 and 45 degrees. You're still in the first quadrant. So no need for plus or minus, just plus. Okay, cosine squared of theta over 2 is 1 plus cosine theta divided by 2. The main idea is that that angle times 2 is this angle. Okay, so the original formula had a theta here, perhaps, and a 2 theta here. Okay, so if we put a theta over 2 here, you double this angle, which is theta. Okay, so 1 plus 3/5 divided by 2, that's 8/5 divided by 2. If you divide by 2, you multiply by half, 8/5 times 1/2. Okay. Some of you had 8 over 10. You should reduce 8 over 10 to 4 over 5, especially since that simplifies. Okay, so that's cosine squared. So cosine is the square root of that. Best answer is 2 over radical 5. Okay, that was cosine squared. Sine squared similar, except that there's a minus. Okay, so same thing, 1 minus cosine theta divided by 2. 1 minus 3/5 divided by 2. 2/5 divided by 2. You can slide the 5 down. Or you can say 2/5 times 1/2, cancel to be 1/5. That's sine squared. Okay, so sine of theta over 2 is the square root of 1 over 5, or 1 over radical 5. I don't mind that you didn't rationalize the denominator, but if you went ahead and did radical 5 over 5, that's okay. And same thing here, 2 radical 5 over 5, that's okay. All right, but again, you don't need a plus or minus because you're in the first quadrant still. Okay, that was based on here. Okay, and a reminder again for quizzes, I'm a lot more lenient. Some things I just let slide by, like I might have let some things go. And of course, those of you who submitted a quiz early, I get a chance to make comments and have you retry something. That's not true for exams, right? So for exams, you only get one-shot deal, and you have to pretty much get it right. Okay, so quizzes, I let some stuff go since it's a precursor to exams, but for exams, I am more stringent and say, okay, this better be right, and so forth. I'm not sure why this machine keeps blinking back and forth between yellow and white for me, but anyway. All right, so that was the quiz. All right. All right, and this Friday we're not having a quiz because we're having a test. So we're here. We only have 6 weeks left. 1, 2, 3, 4, 5, 6, plus final exams. Okay, so we're in November, as you know, so we're finishing very quickly. I only have one section left, 4.9. So most likely I'll finish early today. I'll finish early tomorrow. I'll finish early Wednesday. Let you ask questions. If you don't have any questions, we can stop. Then Thursday, you can have the whole time for questions and answers, but if not, I'll start sneaking in some of the next chapter. And the next exam is this coming Friday. Okay, so we haven't had a test in a while, but you know the way it works. You submit all of this. As you can see, it's our largest chapter. And you don't really have that much to do, per se, because I did a lot of them, right? So I have that 70% rule for homework, but I end up doing, what, half the problems, sometimes 2/3 of the problems, sometimes very close to all the problems. But minimum, I end up doing, what, 1/4 or 1/3 of the problems, I suppose. Okay, in which case you don't have to do that many others, right? Okay, so I'll do more of 4.9, or I'll start 4.9 today, and we have 3 days for that. Okay. Then looking ahead, the next exam, only 3 sections, so it'll only be 2 weeks after that, even though there's a holiday in there somewhere. Let's see, we have Veterans Day coming up next Wednesday, right? Not this Wednesday, but Wednesday the 11th is Veterans Day. Okay, so another 1-day weekend, I guess. So still aiming for test 5 on Friday the 20th. Okay, and then we have a Thanksgiving holiday. And then somewhere near the last week, we'll have exam 6. Okay, so right now it's tentatively on a Thursday this time. Okay, no, but we'll see how it goes. All right, so we're finishing up pretty quickly. All right, so let's get started with law of sines and law of cosines problems. So a quick reminder of where we were last time. Law of sines, law of cosines. Put these on your cheat sheet. And formula for the area of a triangle. So have this convention. If you're given any triangle, please notice right now we do not necessarily have a right triangle. We have any triangle. Okay? So notice there's no right angle here necessarily. So points A, B, and C. The little a is opposite big A. That's the side. Okay? Little b is opposite big B. Little c is opposite big C. Okay? Now, I don't care that you call this A, B, C. You can put the A here and a C here and a B there, or you can put the A there and a B there and a C there, or the A there. You can have any combination that you want. But once you put down, let's say, the big A's, the little a's must go opposite by convention. Okay? So notice the location, big A, little a, big B, little b, big C, little c. So A, B, and C are the points. The angles are the Greek letters alpha, beta, and gamma. Okay. Gamma might be a little bit harder because it doesn't start with a C, at least our letter C, but alpha starts with an A, beta starts with a B, okay, and gamma is all by itself over here. Okay. All right, so here's the law of sines. Again, sine of alpha over A. Think of it as sine A over A. Sine B over B, sine C over C. Okay. For these, you'll quite often be doing the cross multiplication rule. Okay. So what happens a lot is you'll be ignoring one of them. So separately ignore this. You have this and then cross multiply. That times that equals that times that. Or you might ignore the middle one and you go that times that equals that times that, cross multiply. Or you might ignore the first one and go that times that equals that times that. Okay. And then the law of cosines has 3 equivalent forms. If you want to put them all on your cheat sheet, you may, but to me, you can get by with just one of them. So a squared equals b squared plus c squared minus 2 times that, b times c, and then the cosine of the angle that's out here, so alpha. So there are 2 equivalent forms. Okay, so if you want to think of it like, the equivalent forms, just look back over here. Suppose it's b squared that I want. Then it's the other 2 letters, a squared plus c squared. Then look at the form. It's minus 2 times each of these letters. So minus 2ac. Okay, here a was cosine alpha, so can you guess what that would be? Cosine beta. And similarly for c squared, just look at the format here. So how do I find c squared? The other 2 letters, so a squared plus b squared. minus 2ab. Let's see, A cosine alpha, B cosine beta. So what should this one be? Cosine gamma. And again, side note, suppose gamma came out to be 90 degrees. Okay, the cosine of 90 degrees is 0. 0 times all this is 0. That would cover this all up. And you have your favorite Pythagorean theorem, c squared equals a squared plus b squared. So the Pythagorean theorem is a special case, you might say, of the law of cosines. All right, so we're going to start solving the triangle. All right, so again, solving the triangle, they will normally give us 3 pieces of information. Right? 1, 2, 3, 1, 2, 3, 1, 2, 3. Right? 1, 2, 3, 1, 2, 3. They're generally going to give you 3 pieces of information, and we're asked to solve the triangle, which means find everything else. Okay, find everything that they did not give us. Okay. And some things should be obvious. If you ever have 2 of the angles, right? So pretend this one is, I don't know, 80 degrees. This one is 70 degrees. You can automatically find the third angle because you know all 3 of these have to add up to 180, right? So if you ever have a situation where you're given 2 angles, you can find the third very easily. Okay. You do not use the Pythagorean theorem here unless you know it's a right triangle. Okay, so sometimes a mistake that students make is they'll want to use the Pythagorean theorem, a squared plus b squared equals c squared, but that doesn't apply because you don't have a right triangle. Or sometimes students might want to use SOHCAHTOA, opposite, adjacent, hypotenuse. There's not necessarily any hypotenuse here, so you can't do any of that. I mean, the word hypotenuse implies there's a right angle, but there doesn't have to be a right angle. Okay. All right, so here's problem number 1. Alpha is 55 degrees, B is 12, C is 20. Solve the triangle. So find everything else. Now, I want you to notice here, this is what I call you're given exactly 1 piece of information from every letter. Alpha is like A, right? A is 55, B is 12, C is 20. You cannot do the law of sines here. It won't work. Okay? In order to use the law of sines, you have to have 2 pieces of information from some letter. In other words, you need either A and A, B and B, or C and C. Okay? Now, let me show you what happens if I try to do law of sines. Okay? Again, my preference is law of sines. This equation looks a lot easier than this one. I think you would agree. So you might say, why don't I just always do this? Well, you can't always do this. Okay? And here's an example. Okay, they give me 1 of each letter, so to speak, if you count alpha as A. They give me an A, a B, and a C. If they ever give me 1 letter of each, you cannot do the law of sines. Let me show you why. Sine of alpha over A, sine of beta over B, sine of gamma over C. So I put 12 here, 20 here, and sine of 55 degrees here. But notice I cannot cross multiply and solve for anything here, right? Because I'm stuck with 2 letters. So take a look at this. I have 2 variables still, A and beta. So I can't do that. Okay? Or if I try to eliminate the middle one, I still have A and gamma. That doesn't help. If I try to eliminate the first one, I have beta and gamma. So that doesn't help. Okay? So I cannot do law of sine. So I'm stuck using law of cosines. Okay? So you say, well, how should I figure out which of these equations to plug in for the law of cosines? Well, it's pretty obvious. Just pick the one that you don't have. Okay? I do have B. I do have C. Which letter don't I have? A. So that one. And likewise, you do this one if they give me, let's say, A and C, but I can't do anything else. Or if they give me A and B, then I use the third one. Okay, so if given exactly 1 piece of information for each letter, law of sines won't work. Okay, that's what I'm saying here. So if they give me exactly A, B, and C, or alpha, beta, and C, or something like that, okay, you're given exactly 1 piece of information for each letter. Okay, 1A, if you count alpha as A, 1B, 1C, then sines won't work. You have to do law of cosines. Okay. So one more time, say, how do you know which one of these 3 to use? That left-hand side is whichever variable they don't give me. They give me B, they give me C, they don't give me A. So use A squared equals B squared plus C squared minus 2BC cosine of alpha. Okay. They tell me this is 12. They tell me C is 20, 12, 20, and alpha they give me is 55 degrees. Okay, so now it's just a straight plug-in. Okay, I'm going to bring the paper back up to here now. A squared equals 12 squared plus 20 squared minus 2 times 12 times 20 cosine of 55 degrees. And for these problems, okay, you want to be sure that you're in radian mode, degree mode. So let me change mine. Okay, so my calculator switches to degree mode. Okay, so for this section, you have to be in degree mode. Oh, I better hasten to add, on the exam, you're going to have some stuff in degrees and radians, so you might have to switch back and forth between degrees and radians on the test. Okay, the context will usually make it clear. But for section 4.9, when you're solving a triangle, for sure you're going to be in degrees. Okay, so make sure that you're set for degrees on this section here. And you have to be careful when you're switching back and forth. Okay, punches on my calculator, I get 268.68. Take the square root. Okay, you don't need any plus or minus. These are all distances. Distances are always positive, so we don't have any negatives there. Okay, and A comes out to be roughly 16.39. Right. Now that I have 16.39, I put that over here, and then I can do law of sines from here on out. Okay, so I found a 16.39. So now I have all three sides. So I labeled 16.39. And now, for instance, I can cross multiply here, right? That times that equals that times that. And I think that's exactly what it is. So I'm going to go 16.39 sine of beta equals 12 sine of 55. Okay, and I'll show that to you now. 16.39 sine of beta equals 12 sine of 55. So cross multiply. So 16.39 sine of beta equals 12 sine of 55. Divide both sides by 16.39. Punch it in the machine. So 12 sine 55 divided by 16.39 is about 0.5997. Okay. Now I do my inverse sine. Okay, so to go from sine of beta to just beta, you do inverse sine. So inverse sine of 0.5997. Okay, so if you're not sure about inverse sine, sorry. Okay, so you have your sine, cosine, and tangent. Almost all calculators, the inverse functions are right above there, there, and there. Okay, so again, if you make sure that you're in degree mode, and you hit inverse sine of 0.5997. So 36.8 degrees roughly. I'm not sure if you can see that, but 36.8. Make sure you do it on your own calculator. Okay, so this is 36.8. And now that I have two of the angles, right? Once you have two angles, don't do any more trig. You know the sum of the three angles in any triangle is 180. Okay, so anytime you have two angles, just subtract from 180, right? So if I subtract from 180, I get 88.15 for gamma, right? So the triangle solved. A is 16.39, beta is 36.85 degrees, and gamma is 88.15. All right, so I have the triangle solved. What does it mean to solve the triangle? I now have all the sides of all the angles. Okay, so at the beginning, they'll usually just give you three pieces of information. Okay, either three sides or two angles and a side, or one angle and two sides, something like that. Okay, so I've now solved the triangle. I have all the sides, I have all the angles. Okay. All right, problem's done, but I'll dig a little deeper. Okay, which is the largest side? Looks like C, 20. Which is the largest angle? Gamma, 88.15. On the other hand, which of these was the smallest side? Looks like B, which is 12. And what's the smallest angle? Looks like beta, 36.8 or 85 or whatever. Okay, so that leads us to this principle. The smallest side is always opposite the smallest angle. The largest side is opposite the largest angle. I got lazy here. This is ditto marks. Okay, so this is an important principle, and it really helps when you're solving these triangles. Okay, the smallest side is opposite the smallest angle. The largest side is always opposite the largest angle. Okay, and maybe I can illustrate that. I just make up a triangle like this, and then kind of open it up like that. Okay, take a look at this triangle. Okay, maybe I just use my pens. If I get really, really small, right? Go like that. This angle is small. Opposite that is a very small side, which kind of makes sense, right? Now imagine I take this and open it up. Okay, as the angle gets bigger, the opposite side gets bigger, right? So now if you look at this angle here, how about call it theta, and I call that x. As theta gets bigger, right, as I open up the angle more and more, this opposite side gets bigger, right? And if I shorten it, if I get smaller and smaller and go like that, the angle's small, and this distance here is also small. Okay, we'll call that theta, and this is x. Okay, so the smallest side is opposite the smallest angle. The largest side is always opposite the largest angle. Okay. All right, so let's do some more. Okay, alpha is 40 degrees, beta is 87 degrees, C is 115. Okay, so alpha, beta, and C. Okay, this problem is going to be much easier, I notice, because they already give me two angles, right? So right away, what should you do if they give me two angles? Subtract from 180, right? Add these up, 127 or whatever it is, okay, and then subtract from 180, because you know the sum of the three angles in any triangle is 180. So add these up and subtract from 180, and you automatically have gamma. Is that right? Okay, so alpha is 40 degrees, beta is 87 degrees, C is 115. Okay, so I made up my picture. Now again, your picture doesn't have to look like my picture exactly, but you know, once you set down A, alpha has to go opposite. Once you set down B, beta is opposite. And likewise for C and gamma. Okay, so let's see. I put alpha is 40, little a. Beta is 87, little b. And C is 115. Okay, so the first thing to do is find gamma, and it comes out to be 53 degrees. Okay, so I did 40 plus 87 is 127. Subtract that from 180 and get gamma is 53. Okay, so now I have 1, 2, 3 angles. Okay, once I have all the angles and I have one side, then it goes straight to the law of sines because it's much easier. Okay. Yeah, here we are. Gamma is 180 minus 40 minus 87. That came out to be 53. Okay, so sine, think of it sine of A over A, sine of B over B, sine of C over C, even though they say alpha, beta, and gamma. Think of it as sine A over A, sine B over B, sine C over C. In fact, many books, many trig books don't even use alpha, beta, and gamma. They just leave it as A, B, and C. So you can just think of A and A, B and B, C and C. But it's not that hard. I mean, beta even kind of looks like a B, I suppose. Okay, so alpha A, beta B, gamma C. All right, so now I set up the law of sines because I like it better. So sine of alpha, 40 over A, sine of beta, 87 degrees over B, equals sine of gamma, 53 over C, 115. Okay, so how about let's find A, for instance. So maybe cover this up. Cross multiply, right? So that times that equals that times that. Just ignore the middle part there. Okay, so A sine of 53 equals 115 sine of 40 degrees. Divide both sides by sine of 53 degrees. Okay, so 115 sine of 40 degrees divided by sine 53 degrees. Punch it in your calculator. Make sure you're in degree mode. And comes out to be 92.56, it looks like. Okay, so now I put 92.56. Okay, now watch out for this. I have some students do this. So they got A and they got C. So, oh, why don't I just use Pythagorean theorem to find B? Okay. What's wrong with using the Pythagorean theorem? Take a look at the triangle. When can I use the Pythagorean theorem? There has to be a right angle, a 90-degree angle. Is there a 90-degree angle? No, there isn't. It's pretty close, 87, but that doesn't count. It has to be exactly 90 degrees. Okay? So do not just automatically say, oh, I got A, I got C, then I'll do my A squared plus B squared equals C squared. That will not work here. Okay? What will work is go back and use the law of sines again. Okay, so I just use the law of sines one more time to find B. Okay, so that means I can ignore this fraction and cross multiply here, right? B times sine of 53 equals 115 sine of 87. So that's what I got here. B sine of 53 degrees equals 115 sine of 87. And then divide both sides by sine of 53 degrees. And it looks like this. Punch it in the machine. I get 143.80. So the triangle is solved. And yeah, how do you present your answer? You present your answer with the 3 pieces of information that you just found out. Okay, so that way I don't have to look around on your paper, on your homework or your quiz or test, right? And you got stuff floating all over the place. And oh, where's your A? Where's your alpha and all that? So if you just kind of summarize it like this, that'd be great. Okay, so they give me these 3. So you already know what I need, right? I need A, B, and gamma. So there it is, gamma, A, and B. I don't really care about the order, as long as I got it all there. Yeah, see how I did this one also? So from this one, alpha, B, and C are given. So what do I need? Okay, the only side I need is A, and the angles I need are beta and gamma. Right? So there it is. Okay, so when you finish these problems, list at the very end, you know, the 3 pieces of information that you derived. Okay, so that's A, that's beta, that's gamma. Okay, so I don't have to look around. Where's your A? Where's your B? Where's your gamma? Right? It's all over the place. So it's a lot easier if you just give me a quick summary of the 3 pieces of information that you derived for the problem. Okay. Okay, so that's it for that one. Next one I was going to show you is number 9. Let me see if that's what I want here. Yeah, that's what I want. Okay, so use the law of cosines and the law of sines as necessary. Okay, so they give me alpha, B, and C. So alpha, B, and C, do they give me 2 angles? No, they do not give me 2 angles, so I'm stuck. Okay, I have to use the fact that they give me alpha, B, and C. So that's exactly one of each letter. So I must use law of cosines. Okay. So in order to do law of sines, you have to have either A and A, or A and alpha, B and beta, or C and gamma. You don't. Okay. So what can we do? All right. So I draw myself my picture. Alpha is 130, B is 5, C is 7. Okay. So what letter am I missing? A. So use the version that has A squared by itself. So A squared has, then I square the other 2 letters, B squared plus C squared, minus 2 times that times that. So 2BC, and the cosine of which angle? A, so alpha. Okay, then I just plug in. So A squared is B squared 5 squared plus C squared 7 squared minus 2BC, 2 times 5 times 7 times cosine of 130 degrees. Okay, punch all of that in your calculator. A squared is 119.00 almost. Hit the square root button. A is 10.91. Okay, so 10.91 right there. And now that I know this is 10.91, I switch over to law of sines. I like the law of sines better, right? It's much nicer. Right, so sine of 130 over 10.91 equals sine of beta over 5 equals sine of gamma over 7. Okay, so how about cross multiply here? So usually, even though you have this formula for the law of sines, you ignore one of the fractions, right? So if I'm solving for beta, just ignore that last one temporarily. So sine of 130 over 10.91, sine of b over 5, that's an equal sign there. And this is meant to be cross multiply, cross multiply. Okay, so 5 sine of 130 equals 10.91 sine of beta divided by 10.91. Sine of beta is 5 sine of 130 over 10.91, 0.3511. Okay, that's not beta, that's sine of beta. Okay, if that's sine of beta, how do we get beta? Inverse sine. Okay, and again, make sure you're in degree mode. Okay, so sine of beta is this. So I now do inverse sine of 0.3511, right? So again, inverse sine on your calculator is above sine, so you have to do the second function button, right? So second function inverse sine. What was it again? Lost my place here. But 3511. 20.56 roughly. Okay, that's beta. All right, so 20.56, 130. Now, I could do the law of sines to get gamma also, but way easier, of course, is once you have two of the angles, right? I got that, I got that. Why bother doing law of sines or law of cosines? Just use the simple fact that these three have to add up to 180 to find the third angle, right? So now that I know this, and I know this, and I know they have to add up to 180, then I should subtract from 180, right? And so I did gamma is 180 minus 130 minus the 20.56, 29.44. And here's my summary. Okay, so A is 10.91, beta is 20.56, and gamma is 29.44. So separately list all the unknowns. Okay, so again, when you're solving a triangle, there's 6 pieces of information, right? 3 angles and 3 sides. Almost always they give you 3 pieces of information, okay, like 3 sides or 2 sides at an angle or 1 angle and 2 sides. Okay. By the way, they will not give you 3 angles. Okay. If you only have 3 angles, that's not enough to determine a triangle, right? You have to have at least 1 side to go on. All right, so you can see from the original problem, they only give me alpha, same as I need to give beta and gamma. I do give beta and gamma. Okay. Then look at the sides. They give me B and C, so I only need to come up with A. And I got it, so there it is. Yeah, now what I like to do is just label it on the triangle, which is great. Okay, but separately show me on any quiz or test or homework that, you know, these are the things you're trying to solve. Okay. All right, and yes, they can give you 3 sides. 3 sides is enough to determine a triangle, but not 3 angles. Okay, that's a situation where you can't get any one triangle. All right, and I was going to hold off on that until next time because that's it for today's lecture. Okay. All right, so next time I'll show you an instance where we have 3 sides. 3 sides is enough to determine a triangle. The one combination you cannot have is just 3 angles. You can have 2 angles and a side, 1 angle and 2 sides, or 3 sides, but not just 3 angles. That won't work. Okay, so I'll show you that next time. All right, so let me stop the share, and basically I'm done. Check the chat. Okay. Okay, so let me check the questions. Okay, I got that. What do we need in order to use the law of sines? Okay, maybe the best way to, if you don't want to think about anything, you can just say, try to use the law of sines until you get stuck. Okay, if you get stuck with the law of sines, then you have to do the law of cosine. Okay, but if you want to know specifically, if they always give me one of each letter, one of A, one of B, one of C, you must do law of cosines. In order to do law of sine, you have to have A with A, B with B, C with C. Okay, like alpha and A, or beta with B, or gamma with C. Okay. And let's see, if they give me A, okay, in order to use the law of sines, you have to have A and alpha, B and beta, or P and gamma in order to use the law of sines. Let me just go back and show you this again. Get there. Okay, law of sines, right? And we had the law of cosines, but the law of cosines is a much harder situation. I think you would agree. So I prefer to do a law of sines, but in order to do a law of sines, I have to have this and this, either alpha and A, or beta and B, or gamma and C. Okay. So if they give me only one of each, like suppose they give me A, B, and C, I can't cross multiply and eliminate anything. Okay. Or if they give me alpha and B and C, that's not going to help. Okay, because you won't be able to solve for anything. But take a look at here. Suppose they give me alpha and A, right? And then they give me beta, I can cross multiply and figure out the B. Or let's suppose they give me gamma and C, and they also give me B, I can cross multiply to figure out the beta. Okay. So to use the law of sines, you must have both alpha and A, or beta and B, or gamma and C. Otherwise, you're stuck doing the law of cosine. Another way to say it, the law of cosine, they're generally going to give you exactly one of each letter. One A, one B, and one C, if you allow alpha, beta, and gamma being considered one letter. There. Okay. And let's see. I think that's pretty much it for that. Okay, anybody else want to ask me anything? Otherwise, we're done for the day. We can continue tomorrow. All right, that's it for today, folks. So have a good day, and we'll see everybody tomorrow. Okay, thank you. Bye. Have a good day, everyone.